Hello, welcome. I'm Mr. Sawyer, and this is our honors geometry class, lesson 9-6, where we'll be dealing with other angles in circles. You've seen before we did central angles in circles, and we've worked with inscribed angles. Now we'll be working with different types of angles that occur inside and outside of circles. The two types of angles that we'll be working with today are angles that are located on the interior of a circle and angles that are formed on the exterior of a circle but have lines that intersect a circle. So let's take a look at the first example here. First, when we have an angle on the interior of a circle, but it is not a central angle, we can see the theorem here says that the measure of the angle is formed by two chords that intersect inside a circle is equal to half of the sum of the measures of the intersected arcs. So, saying that in other words, if we want to find the measure of this angle, we need to identify a few extra parts. The first, we need to find the intersected arc that this interior angle opens up to. So we see the two sides of the angle open up to this piece of an arc, which I will just say is A degrees for right now. Second part, we need to find the angle vertical to the angle that we're working from. So here's angle 1. We know that angle 1's vertical angle is right here, and we know that these are in fact equal because they are vertical angles. And then the last part, we want to find the measure of the arc that that angle opens up to. We will label it B degrees. Okay, if we use this theorem correctly, we know that the measure of angle 1 is equal to 1/2 times the sum of the two arcs, which we would say 1/2 times A plus B, filling in the numbers. And that works with any other angles other than that central angle. It actually works with the central angle as well, but there's a shortcut for that one. Let's take a look at an example where we solve a problem with that same information. Here we have circle T. The measure of arc AC is 100 degrees. I'll just label that 100 degrees. And the measure of arc BD is 70 degrees, so I'll label that one as well. And we want to find the measures of angles AOC. So angle AOC located right here, I'll put a 1 in there to mark it. And the measure of angle COD, and I'll put a little 2 in angle COD. So first, we want to find angle 1. We take a look to see which arc opens up to angle 1. We find the vertical angle and the arc that opens up to, and we write out our formula. The measure of angle 1 is equal to 1/2 times the sum of the arcs. So 100 plus 70 is what we write in here. Solving this problem, we do parentheses first, so we get the measure of angle 1 equaling 1/2 times 170, and then the measure of angle 1 is equal to half of 170, which is 85. All right, next step. Now that we know the measure of angle 1 is 85 degrees, how can we find the measure of angle COD, which I labeled 2? We could use the arcs that it intercepts, but it's a little bit easier. We have a linear pair here. These add up to 180 because they make a straight line, so angle COD is simply 95 because 85 plus 95 equals 180. Let's take a look at one more example with these types of angles. We have to find the measure of arc AB. If the measure of angle AOB is 120, and you can see that the measure of arc CD is 160 degrees. So we'll label the information. Arc AB is this arc right there. I'll label it X degrees because it's unknown. We're told that the measure of angle AOB is 120 degrees, so we fill that in. So this we're going to use the same exact formula, but the information that we know is in different places. We want to find all of the arcs that our angles intersect. We want to use arc AB because we are interested in finding it. We see that 120 is an interior angle that opens up to it. We look for the vertical angle, also 120, and the arc that angle intercepts, which is 160. So we have all of the information that we need. the measure of the angle, which is 120 degrees, is equal to 1/2 times the sum of the arcs. So one arc is x, the other one is 160, so it would be x plus 160. Solving this problem, we just will follow the order of operations. 120 is equal to, I guess I could distribute the half actually. Let me solve this slightly different. I will multiply both sides by 2, eliminating the 1/2. 1/2 times 2 is gone. We'll do the same thing to the other side. So next step, 2 times 120 is 240, which is equal to x plus 160. Next step, we subtract the 160 from both sides, and we get our answer. So x is equal to 80. Which means the measure of arc AB is 80 degrees. All right, moving on. Like I said, there are 2 types of angles that we're going to be discussing today. We've seen examples of how to solve all types of problems when we have an interior angle. Now let's move on to the second type, when there's an exterior angle. What are the properties that we want to look for? So the theorem states that if we have an exterior angle, it's equal to half of the difference between the intercepted arcs, as you can see here. So if I was to write this out as a formula, we would say the measure of angle 2 is equal to 1/2 times the difference of the arcs. We'll find the intercepted arcs. First, the angle intercepts this portion of the arc, which I can label A degrees. And if we follow the angle out, we can see it also intercepts this arc, which I'll label B degrees. So it's the difference. We take the bigger one minus the smaller one. There we have the exterior angle is equal to half of the one arc minus the other arc. All right, very similar to the other formula, but a minus instead of a plus. We can have exterior angles formed in 3 different ways. If we have 2 secants, you can see that the intercepted arcs are located here and here, like the example that we just saw. So that means the measure of angle 1 is equal to 1/2 times the difference of the 2 arcs. If we label them A and B again, we have A minus B this time, just because I labeled A as the larger arc. Here, where are the intercepted arcs when we have 2 tangents? This one is probably the trickiest. We can see the tangents only intersect a circle in one spot. So the first intercepted arc runs from one point to the other point of tangent C. And the second arc is the rest of the circle, all the way around. And again, the formula would be the measure of angle 1 equals 1/2 times the difference of the bases, difference of the arcs, one arc minus the other. And finally, a secant and a tangent. To identify the arcs, we can see that the angle intercepts arc 1 and arc 2. And we use the exact same formula. Let's take a look at 3 examples. Example 3 on your corresponding worksheet, we have an exterior angle. We can see that it intercepts 2 arcs. One that measures 30, one that measures 80. So the measure of angle 1 is equal to 1/2 times the difference of the intercepted arcs, because it's an exterior angle. So we say 80 minus 30, and we solve. The measure of angle 1 is equal to 1/2 times 80 minus 30 is 50. And finally, the measure of angle 1 is equal to half of 50, which is 25 degrees. Next example. Here we have a secant and a tangent coming together. We want to find the measure of angle C, which I can label as x. If the measure of arc A to B is 120 degrees, so here's arc AB, and we label it 120 degrees, and the measure of arc BD is 70 degrees. So there's a trick with this problem. Our angle intercepts 2 arcs, but those 2 arcs are not both known. We have this first arc on the inside, 70 degrees, The second arc that is intercepted is arc AD. So we have that unknown as well as the angle. So we have to be able to find arc AD before we can find our angle. You know that the sum of all of the degrees of a circle is 360. So we can add up the angles that we're given. 120 degrees of the arc plus 70 degrees of an arc is equal to 190 degrees of an arc. The total arc of a circle is 360. We take away the 190 that we have. We can borrow. 0 minus 0 is 0. 16 minus 9 is 7. And 2 minus 1 is 1. Which leaves us with this arc, AD, equaling 170 degrees. Now we're ready to set up our equation. All right, so the measure of angle C is equal to 1/2 the difference of the intercepted arcs, which we now know are 170 and 70. So the larger one first, 170 minus 70, and we are ready to solve this problem. The measure of angle C is equal to 1/2 times 170 minus 70 is 100. And that means that the measure of angle C is equal to half of 100, which is 50 degrees. And for our final example, I've got a tricky problem here. Two tangents, we have an angle given, and that is all that's given. So we want to find the measures of arcs AC and arc ADC, given that this angle, angle B, is 65 degrees. This one's tricky because we have no arcs with our formula. We know that the measure of angle B is equal to half of the difference of the arcs. So 1/2 times the difference of the arcs, which we still don't know. The measure of angle B is 65, so we could fill that in, which is equal to half times the difference of the arcs, but we don't know either one. So in algebra, we know if we don't know something, we assign it a variable. I'll assign the smaller one an x. Arc AC is now x, which means I can represent arc ADC in terms of x, knowing that the entire circle all the way around is 360. This piece and this piece together add up to 360. That means this arc that's left up here is the entire circle, 360 minus this portion that we don't need anymore, which is represented by x. So that entire expression is our larger arc, our major arc in this problem, which we can fill into our problem. So the angle, 65, is equal to 1/2 times the larger arc, which is 360 minus x, minus the smaller arc, x. And we're ready to solve. We have one equation, one variable, we're good to go. 65 is equal to, I can combine my x's, so 1/2, open up parentheses, 360 minus 2 x's. And this time, instead of multiplying out the 1/2, I'm going to distribute it, since it will distribute nicely. So 65 is equal to half of 360, which is 180. Minus half of 2 x's leaves us with 1x. Next step, I'll add x to both sides. So when I add x to this side and to this side, I gave myself a positive x. Negative x plus x is gone, but on this side I have x plus 65, which is equal to 180. And finally, subtracting 65 from both sides gives us a measure of x being 115 degrees. So that's half of the problem. We know that x is arc AC is 115. And we're ready to find major arc ADC, which 360 minus 115 will get us that answer. So 360 minus 115. We have to borrow. 10 minus 5 is 5. 5 minus 1 is 4. And 3 minus 1 is 2. So the measure of arc ADC is 225 degrees, and the measure of arc AC is equal to 115 degrees. And that is it. Thank you. All right, great job. Don't forget, review all the properties that we discussed today and bring those notes to class. Thank you.